Welcome to the Long Thread podcast about spinning, stitching, and weaving by hand. The podcast is presented by Long Thread Media, publishers of Spin-Off, Handwoven, Piecework, and Little Looms magazines. Find us online at longthreadmedia.com. Trinway Silks is where weavers, spinners, knitters, and stitchers find the silk they love. Select from the largest variety of silk spinning fibers, silk yarn, and silk threads and ribbons at trinwaysilks.com. You'll discover a rainbow of colors thoughtfully hand-dyed in Colorado. Love natural? Trinway's array of wild silks provide choices beyond white. If you love silk, you'll love Trinway Silks, where superior quality and customer service are guaranteed. You're ready to start a new project but don't have the right yarn. Or you have the yarn but not the right tool. Yarn Barn of Kansas can help. They stock a wide range of materials and equipment for knitting, weaving, spinning, and crochet. They ship all over the country, usually within 1 or 2 days of receiving the order. Plan your project this week and start working on it next week. Visit yarnbarn-ks.com to get started. I'm your host, Long Thread Media co-founder Ann Merrow. Sally Fox is known worldwide for her work in naturally colored cotton, which she's made available through her companies Fox Fiber and Vreesis. She spoke to me from her California farm despite some technical challenges, so you may hear a few quirks in the audio. I hope you'll enjoy the conversation. Sally, thanks so much for being with me.
Thank you for having me.
So, I've had this idea that I sort of know a little bit about what you do, but I thought I would do some research. What I'm seeing is Sally Fox is an inventor. Sally Fox is a genetic engineer. Sally Fox is a farmer. How do you describe what it is that you do?
Well, number one, I am absolutely not a genetic engineer. In fact, I would say my career was really shortened artificially by my stance against genetic engineering. And it was typical of all of the people in agriculture in the 1980s. Any of us who questioned anything about genetic engineering were ostracized from the scientific community in agriculture. For example, the rice breeder at UC Davis had some questions about the technology and was fired and went on to breed for Lundberg organic rice. He became their breeder, a private breeder, but that's what he had to do after he lost his job, lost his position at the University of California. The vice president of my company, the late Dr. Wally Hoffman, questioned the technology in the early 1980s and also lost his job, went on to work for the USDA, and then went to work for my company in the late 1980s. So the repercussions for any of us in agriculture who questioned the safety of the technology was swift and brutal. We lost our jobs at the land-grant universities or we lost our reputations as being serious scientists. And many of us went into the world of organic farming where at least classical breeding, which is what I do, is the accepted means of developing varieties for organic or biodynamic farming. So I don't describe myself as anything other, and I do not describe myself as an inventor, although people like to call me an inventor. And that maybe there's an inventiveness to my work, but inventing in my mind implies sort of taking something, kind of inventing something completely new. And what I've been doing is trying to bring what I believe are the most important qualities of these cottons that were sort of left behind by the regular cotton industry. Cottons were always grown in many colors. White is a great color because you can dye it. And it seems as though, and everyone had believed this to be true until I did my work, that you couldn't really improve the length, strength, or other fiber qualities of the cottons that were colored, but you could increase the length and strengths of the white cottons rather easily. And that's why the entire cotton industry kind of gravitated towards white cottons. In addition, they had the advantage of being easy to dye. White is easier to dye than if you start if you start with a color. And people wanted the ability to dye things readily because the invention of the mechanized spinning and weaving equipment corresponded with the invention of synthetic dyes, which totally lowered the price of applying color to textiles. Because all of us anyone who does natural dyeing knows it's a craft dependent, heavily difficult. It requires skill, craft, and a lot of materials to do natural dyeing. And there are issues with the lightfastness or water fastness or laundering of natural dyes. And so synthetic dyes really represented a huge leap, as did mechanized spinning and weaving. So my contribution to all this was to, with classical plant breeding, not genetic engineering, develop varieties of naturally colored cotton that retained their innate pest and disease resistance and retained their capacity to grow very deep, large roots that allowed for not using synthetic fertilizers. I tried to maintain what I considered to be great and amazing qualities, those qualities that allowed for organic farming, with the addition of improving the fiber length and strength, as well as color intensification. And this is where the hand spinning and hand weaving community comes in, because alone in the world is my project in terms of what people have been doing with naturally colored cotton to try to get them into industry. The reason mine is unique from everyone else's is that I enjoyed the support of the hand spinning and hand weaving community, because I was a hand spinner and hand weaver. Even one of the jobs I had while I was young, working in a lab, I worked part-time as a production weaver at a weaving shop in Menlo Park, which is where I got my first spinning wheel. So my hobbies were hand spinning, hand knitting, hand weaving. Since I was 11 years old, this was my passion. But what I studied was entomology and agricultural sciences with the hope of reducing pesticide misuse. So my sort of professional life was so focused on pesticide misuse in agricultural crops. And my personal life was completely madly in love with textiles. So when they came together with these cottons, but in the beginning, I funded all my work just by my jobs. I would work on these cottons on the weekends and on any evenings, any holidays. And I devoted many years of my life at first while I had my jobs paying for things. But I didn't have the money to pay for lab testing. So what I did was I sent my fibers that I thought I had made improvements with to the Master Hand Spinning Guild. I received the help from 3 of them. One was in Madison, Wisconsin. I believe it was Madison. Then the other was in Albany, California, and one was near Santa Cruz, I believe. And the Master Hand Spinners, I was young, and these were tended to be people a little bit older than I was to quite a bit older than I was. And they used techniques that I didn't know of. For instance, when I spin, I only and let it sit for a while before I would ply it or use it. Whereas they used this other technique, which was spinning, plying, and scanning and boiling it. And they made the most important discovery. And that was that many of my cottons, when you boiled them, the color went away. Others, the color got darker. So this was the actually most important thing, and what differentiates my breeding programs from everybody else's in the world, which now there are a few of them. Finally, because of my cottons, in the 90s, there was interest in my cotton industrially, and that kind of dissolved when the textile industry changed. But it's coming back now, but now all these people are breeding colored cotton. And indeed, the Chinese had a $40 million genetic engineering of colored cotton program that they started in the year 2000. And what everyone else's programs suffer from is the fact that they don't seem to have any system in place to evaluate and differentiate those whose color washes out and those whose colors get darker. With boiling is kind of like a fast forward of laundering. So in my system, I have since 1985, when the hand spinners the master hand spinners informed me of this, since then, I have been selecting only those that got darker and with boiling, and not only get darker, but I have been selecting for those with amplified darkening. Like, I don't want just a little darker. I want it way darker. and this is something you can select for, and this is what I have been selecting for. So not only is the fiber quality improved enough to be spun on machinery versus hand spun, but the color doesn't wash out when you wash your clothes. Nor another issue in processing at industrial levels is something that I always called crocking, but I don't believe that's the correct term. It's this thing where those who weave know you will make a warp. In industrial warps, they always size the yarn. Mm-hmm. And so you size it and then you have to de-size it. What I have had to test for when I get to the point where the cotton is close to being a variety is you have to test to make sure that when you size it and then de-size it, the color doesn't get released and make like splotches on top of other, the white cotton that if you made imagine a ticking stripe. Mm-hmm. And that was in fact the first fabric that I produced to prove that my cotton did not do this splotching thing. So in the industry, everyone said, oh no, you can't use colored cotton, it's too short. Then they said, oh no, you can't use colored cotton because the color washes out and or it splotches all over the rest of the textile. So every single thing that everyone said was the problem, I had to prove that the varieties I developed did not have that problem. Mm-hmm. And the way to prove the non-splotching thing was to pay to weave a ticking stripe where you have these tiny stripes. And then you would see with the white and the brown, you would see very clearly if there was any kind of splotching going on. And so in the beginning, I only had the help of other hand spinners to evaluate. And I also had the financial support of these hand spinners and hand weavers buying my products. And that is what helped me keep going, because it's not like I had somebody funding this. I had me funding it with my job as a lab scientist. Mm-hmm. I worked in agricultural, biological control, and mainly in biological control insects in labs and in the field. And so all my work, my paid jobs, I lived as frugally as I could and rented land to grow these cottons on and did all this work until I finally was able to prove to the industry that this was actually a viable product that could be used at industrial scale. And that is when I was able to finally quit my job and just do this full time.
And now a word from our sponsors. Brown Sheep Company is a 4-generation family business bringing you high-quality wool and natural fiber yarns. We spin and dye U.S.-grown wool into hundreds of vibrant colors at our mill in western Nebraska. Our mill has something to offer for every craft, from well-known knitting and crochet yarns to wool roving for spinning and felting. We offer U.S.-made needlepoint yarns as well as yarn on cones for weaving. Learn more about our company and products at brownsheep.com. And now back to the show. So this is really a calling. I mean, that's the kind of effort and long-term drive that, if it's something that you're doing on the side, it's because you really believe that it's not only possible, but really important.
Yes, this is the most important thing that I could think of for changing the story on textiles. Because what started all this, what motivated me to devote my life to this was back when I first had gotten my loom. I got my first loom when I was about 20. and I went back to, I had worked at an insect research facility in high school and then later in the middle of college. I worked in the insectary, raising insects. And the reason I had this job was because I had a high school teacher from Kenya who had inspired me to go into entomology. And she had found this internship for me that changed my life. It was a company that did research on insect pheromones, which is how insects communicate with each other, and insect hormones. And I worked in the insectary, raising the insects for the scientists to do all this identification and of the pheromones and hormones and synthesis of them and evaluating if the synthesis was correct and all that. So the guy that I worked the longest for was sent by the Cal Academy of Sciences in San Francisco to the Amazon to go collect these cutter ants, which in fact, it's so funny because at the Cal Academy in San Francisco, you could go and there's a whole cutter ant exhibit. And I think to myself, oh my God, this is what he did. He went down there and he got these for the Cal Academy, found these ants and brought them up and got them going. And what happened is I took his place for 6 months so he could do that for the Cal Academy. And then he didn't want to come back. And I ended up working there for 2 years in the insectary. And while I was working there is when I got my loom and when I worked part-time as a production weaver at this weaving shop. I worked in the shop selling yarn and I wove. The people who worked in the shop also did production weaving for the things they sold. So I had work experience, both as in entomology and all these things to do with agriculture, but also weaving. And when I decided I had to go back to college and finish my degree, and I did. And when I went back to college, I taught hand spinning as one of the ways I made money. I was a member of the San Luis Obispo Hand Weavers Guild, and a number of the members were interested in learning how to spin. And I learned to spin when I was 11. I was a good spinner. I wasn't the best spinner, but I was a good spinner. And I could spin every fiber. I took a class, a full 1 week class. It was a big part of my life, spinning. So I taught spinning one student of mine. Her name was Dorothea Thompson. She was probably in her late 60s then, my age. Yeah. And she had a daughter who was in a nursing home and eventually died. And what had happened was her daughter had been a art teacher, a high school art teacher. Tie-dyeing was the thing. This is 1975 or 6 when I'm teaching Dorothea how to spin. And her daughter had been teaching art in the late 60s, early 70s in high school, doing tie-dyeing without wearing gloves. And the dyes migrated to her brain and killed her. Her daughter died from the poisoning from dyes.
Wow.
And I was shook up beyond words. And back in those days, there was no Google or anything, right? I went to the library to look up who makes dyes, right? Because a lot of people in hand weaving and hand spinning enjoyed doing, e-cut, all the tie-dyeing, all this stuff was exciting. It's beautiful to dye things. And so it's beautiful to dye things. And what happened, though, it was shook me up so much that I looked to see who makes the dyes. Turns out the very companies that made pesticides all started out by making dyes. That's how they all formed. The synthetic dyes were the first step towards synthetic pesticides. And so that made me completely focus on, from that point on, I would only use natural colors of natural fibers in my spinning, in my knitting, in my weaving, period. No dyes, nothing dyed. And it was like a scavenger hunt to get all these colors. And for some reason, I had friends or a connection with someone at the San Francisco Zoo. And I was able to, I remember they let me go collect the camel hair and the muskox hair from all the animals, right? And so camel, that color was really hard to get, actually. And so later, when I was working for this cotton breeder, I finished college. I went into the Peace Corps. I worked in West Africa on pesticide misuse issues and pest management with rice and peanuts. They call them ground nuts there. And was exposed to terrible pesticide mismanagement issues. And then I came back and went to graduate school in integrated pest management. So that remained my focus, preventing pesticide misuse and overuse. And in my heart, though, I had started out as a kid. At the same time I learned how to spin as an 11, 12-year-old, I got into organic gardening. So I believed that organic was the way out of this morass. But my education was in something called integrated pest management, which was all about using pesticides with accuracy and with responsibility, and to use them in a way that would minimize harm and minimize the chance of the operator getting cancer or whatever, right? That all the price for pesticides are borne primarily by the people on the farms handling them.
Wow.
So that was my passion. And therefore, when I came across these cottons, I was working for a cotton breeder who was breeding nematode-resistant cottons, and I was his pollinator. And he was an older man. He was in his 70s when I was hired. This was right after grad school. And I came across this bag of cotton in a drawer that was camel colored. And there it was. Wow. I'd gone all this length to get camel hair from the zoo. And later there began to be companies that offered all these fibers in mail order that you could buy. But color in fiber is precious. And in cotton, it was pretty much not something I had seen. And when I asked him about it, he said that the breeder for the USDA had been giving all these seeds to all the breeders in hopes that they could, kind of breed the pest and disease resistance from these colored cottons into the white cotton varieties, and therefore reduce pesticide use. But I saw them and thought, whoa, this is a gorgeous color. Why aren't we using the color? And he said, there's no market for colored cotton. And I said, why don't we make a market for colored cotton? He said, why don't you make a market for colored cotton? Here, you can use this part of the greenhouse. And the job was only a summer job. And I had all these jobs in agriculture for counties, for private farms, always doing integrated pest management stuff, and then later biological control. And during all those jobs, I kept all these plants, and they were in pots. I had all these cotton plants in pots that I took with me to all my jobs and kept making crosses and growing up their offspring in other pots until I could lease land large enough to grow out all their offspring and all offspring of the offspring. So very soon it turns into that you need acres. From a few plants in pots, you soon need acres, and you need an enormous amount of energy to tend all these plants organically without using herbicides. And that's how it happened. I believe still that these cottons of intrinsic color, as long as they could be processed on a machine and as long as the color isn't problematic, that they can make a profound difference to the world if they're grown at scale. And in addition to the fact that they have this color already, they have other qualities, like they are all naturally microbial resistant. And the brown, all the tannin-based brown colors are fire resistant. And that is a big deal. Not only are they fire resistant, but they have the elasticity of wool. So they are as flammable as wool, which is not as flammable as normal cotton. And they have the elasticity of wool. So anyone in textiles, if you sew with wool fabric, it has this. It has a malleability and a hand that cotton is a different hand. But these cottons have the hand of wool. They have spring. They have...
Like memory?
Yes, that's the word. They have memory. That's a big deal for cotton to have memory.
It's huge. The stories that you hear about cotton are that it's extremely flammable and that it has no memory. So that's amazing.
Yeah. Isn't it? And then if you take the brown cottons, you only need as little as 20% brown in the fabric, and it passes a number of tests for flammability. But there are various apparel tests for certain. It used to be you had to have for a fleece fabric to be on the outside, not on the inside. They had to use at least 12% polyester in there to pass whatever was required. And it takes 17% of my brown to pass that same test. So you wouldn't have to use polyester.
Wow.
But then you think about, so I have these customers now. I have one mill customer in the world, and they're in Japan. They have customers. They spin the yarn and make the yarn available to their knitters and weavers in Japan. And a number are making underwear. And I wear the underwear. And also they made a bunch of face masks that I wore during the pandemic. And the thing is, for a face mask, and it makes a big difference that it's antimicrobial. You don't get mask knee. Mm-hmm. And it's soft on your skin. And you're not, anyone who's in a medical profession, I was giving them to all my friends who are nurses and stuff to wear under their mask, what was right next to their skin. And so, because they had to wear masks all day. Mm-hmm. And it matters.
The theme that I'm seeing here is that your work is partly about avoiding certain negative traits, but almost just hand in hand are these positive qualities that go along with it. Obviously, the color is the first thing, but it's this sort of virtuous connection of organic and beneficial with enjoyable and, nice to work with and nice to wear.
Yes. And this was the first cotton grown organically at scale in the world. Mm-hmm. It was here in the United States. Before the organic, what we see nowadays as large-scale organic, that is white cotton dyed, all these colors. And before that became what everyone thinks of as organic, it was these cottons were the organic cotton because they don't on their own need fungicides or pesticides. And I'm talking about they don't need pesticides in places where they were spraying 12 times a season for insects. They're seriously pest resistant, not this sort of kind of pest resistant. Mm-hmm. So back in the late 80s, I got a contract with a mill in Japan that ordered hundreds of bales of these colors. It started out with the Emperor of Japan's coronation in 1989. They were trying to make a particular garment and needed green cotton for it. I don't know why, but I grew the cotton for them. And then they put a lot of effort into developing the market for these cottons in Japan. And their orders continued, and they were fair. They gave me a good amount of money to grow these cottons, and I decided this was my chance to figure out how to do organic cotton at scale rather than just my breeding nursery stuff. Because I do the breeding nurseries, which are, by that time, my nurseries were 10 to 20 acres of all these plots, right? Wow. They start out small, but you just soon have so many generations and so many different seed lines you have to go through and plant up. You get maybe 1 out of 100 is something better than what you normally have. And you have to keep growing all these plants up to get the 1 in 100. And of the 1 in 100 that you save and analyze by getting the fiber data and spinning and boiling a piece of it, out of the thousands of plants I would select every year this way, I might pick a couple of hundred. It's just a lot of winnowing, getting the best every year, growing them up, but growing enough of them that you can still pick the best of those. This is what classical breeding takes, a lot of plants growing out, and you, the breeder, looking at each one, feeling the fiber of each one.
As you're developing these different strains year after year, how many colors would you say that you have now? We tend to think of brown cotton as being this sort of catch-all term, but there's so much more to it than that.
Yes. So I call them color families. And I consider the tones being the colors you see in wood and the colors you see in leaves. So think about all the different colors of wood there are. There's ebony, there's redwood. There are lots of woods that are tan and brown. It's a vast collection of hues in the families the tannins are the base. Tannins are a very large class of compounds that we think of tannins in tea and in wine, and they're all beneficial for our bodies when we drink them, right?
Mm-hmm.
And I believe that could be perhaps this is also beneficial for our skin, right?
Mm-hmm.
Don't know. I haven't had the money to assess that. The antimicrobial and I think some of the fire resistance is coming from the tannins. And the tannins are the basis of the wood-toned colors that we see in these cottons. And there is a vast range of brown, of what people would say browns.
Mm-hmm.
And then in the leaf colors, we're looking at all these different colors of greens. And they are not based on tannin. They're based with suberin wax. And this is a type of wax that is placed between every layer of cellulose. And this is a really neat part about cotton that a lot of people don't know. If you cut a tree in half and you look at it, you see rings, and a ring is for every year, right?
Mm-hmm.
That's how you figure out how old the tree is. With cotton, if you cut it in half and look at it on the microscope, there are actual rings of cellulose, and there are 30 to 45 rings. And each ring, instead of a year, is a day. So when the plant is creating the fiber, that is one cell that's growing off the surface of the cotton seed. Its first 10 days, it creates the length of the fiber. And the next 30 to 45 days, it produces a ring, a layer of cellulose every day until the fiber is finished, whatever its desire, however many layers it does. And if it's green, if it's in the green color family, a leaf colored family, it produces a layer of suberin wax between every single layer of cellulose. If it's a tannin-based, a brown, or a burnt sienna, or an ebony, if it's any of those tannin-based, the color is placed in the very middle of the fiber, what's called the lumen, and in the surface outer layers of cellulose, but not in between every single layer. So they're laid, the color elements are laid down in different places on the fiber. And in addition to where in the fiber the color is placed, the placement on the fiber itself and around the seed have specific patterns. And I have a whole system. If you follow me on social media, I often share these little breeder cards that I have. And
they're gorgeous. They're so beautiful.
You know, well, thank you. And what they are is I take one seed from sort of the inside of the bowl, the cotton bowl, one seed from the outside of the bowl. We make like a halo, the fiber halo around it, and I glue it onto those cards so that someday when we have the technology, which I think we're close to now having, to digitize the patterns, that we could analyze the pattern of the colors on the inside, the outside, and how the inside has no light, very little light exposure. The outside of the cotton ball has tremendous amount of light exposure. And so the tannin-based colors develop in sunlight. The suberin-based colors are changed by sunlight. And so we have all of these different interactions going on with the maturity of the fiber, the way they react to light, and in addition to how they are on the plant, the spinning and boiling allows us to see what it will be after laundering. But then there are all sorts of other ways for the color to be either fixed or brought to the final laundering, should that be the way that we want. Like in the 80s, when I was selling to a lot of hand spinners and hand weavers, people then used to get the indigo to oxidize, many people used ammonia, which is kind of a dangerous thing. You don't want to do it in your house. But a lot of people said to me, have you seen indigo is green until it's oxidized to blue? And they said, well, what do you think your green would go blue? And so we tried it with the ammonia, imitating how the indigo dyers were using ammonia to make that shift. And indeed, the color goes teal, almost blue.
Wow.
With the varieties that I've developed. It's not something I do myself, I don't trust being around ammonia in the house like that. But I have one yarn on my website that was done at a facility that had the old-fashioned mercerization system using ammonia, and it shifted it to this most beautiful teal color. Then natural dyers use something called ferrous sulfate as a mordant often. Mm-hmm. That shifts the brown and the green into the gray tone. So there's so much we have yet to learn about how we might shift these colors without dyes, without synthetic dyes, but would be considered normal textile processing. Mm-hmm. And, it's just me doing all this. I don't have any funding except what I come up with. And it's been particularly challenging for me to handle all the people that sort of jump into colored cotton, offer products to the marketplace that I sort of started. And they make enough money to keep their small businesses going. And this is fine. But my whole reason I started ever doing this, selling at all, was to fund research. And I find myself frustrated as I age that I'm not able to do the research that I believe should be done on these cottons. And I'm limited by how much I can do in a day. I mean, I'm the one who ships out the orders. I'm the one who grows the cotton, breeds it. Everything is too much for one person. Back in the 90s, when I had a company with people working for me, and we had, at that point, the maximum we got to 38 spinning mills around the world that were buying containers, and a container load of this cotton is like 88 bales fit into a container. We were making a difference on the world stage in terms of producing thousands of acres of certified organic cotton. I helped write the standards for organic textiles. This is before they allowed dyes in. This is when organic textiles meant no synthetic input in the farming and no synthetic inputs in the processing and the fabrication of the product. So the first organic textiles were all synthetic free, right?
So one thing I wanted to ask you about is that you've talked about how organics and avoiding pesticides have really been a theme all along. But I've been reading that some of what you're currently working on is carbon sequestration and terms that we think of as being more recent in terms of wanting to make a difference for the planet. Can you tell me a little bit about your carbon sequestration and your sort of rotational approach?
Well, that is what organic is. And the organic industry has not been very good at explaining the whole reason. I can do our organic as from the entomological, people use pesticides, let's not use pesticides. And I found that there's so much more to organic than what I was knowing about. The purpose of organic, why is it even called organic? And that's because they're talking about the organic matter in the soil. And how do you get more organic matter in the soil? And what is carbon sequestration? It's bringing organic matter into the soil. So when you go to the old legacy organic farms, the farms around me, a lot of us older organic farmers, our soils are far higher in organic matter than any of the conventional farms around us. Our soil, like out west here, we have a large organic dairy named Strauss Organic Scenery. And Albert Strauss, the one who brought the farm into organic, his dairy into organic. He's my age. He went to Cal Poly when I went to Cal Poly. And we were all told at that time, no way could organic you could never produce crops using organic methods. It would never work. The world would starve. It can't be done. You can't do it. This is what we all wanted to do. And they said, no, it can't be done. So many of us spent our lives proving them wrong. And Albert did that with the dairy. So the organic matter on the soils on his dairy, where his cows are like 10 times that of what everybody else's is around. And if you go to the Full Belly Farms, this large organic farm near me, their soils, the average out here for soil organic matter is 0.5% in the soil. And they have like 8% organic matter in there. So when you aren't selling vegetables to someone who's worried about pesticide residue, when you talk to other organic farmers, what do we talk about? We talk about our soil organic matter. We talk about how do you increase the soil organic matter. That's why it's called organic farming. This is the whole thing. And so lately, there's this interest in sequestering carbon as a means of bringing income to farmers from all these carbon credit things. Mm-hmm. So polluters pay to others to sequester carbon for them. So there are whole financial systems at work to pay farmers to sequester carbon. Mm-hmm. And the techniques that have been documented and are paid for by these large carbon credit, whatever they're called, the carbon credit, there's a name for it. Maybe you'll remember what carbon credit, I don't know. But in any way, you get paid so much for using a cover crop, paid so much for using compost. They pay you to do various practices that all came from organic farmers. Like, where did you came up with all that? There were no cover crops to buy seeds from if we hadn't been buying seeds from these seed companies so they could become seed companies large enough to offer a large amount of seeds in 50-pound bags that you can just buy. So we started the whole conversation, but somehow the general public hasn't been kind of clued in on all this sort of technical jargon that we all talk about. The person buying the organic food is thinking about pesticide residue it doesn't have, mm-hmm. right? And they're not thinking what they're doing really is paying the farmer to have a crop that sequesters carbon. So the things I do on my farm are standard issue organic practices, standard issue biodynamic practices. And yes, they sequester carbon.
Well, okay, but I had an ulterior motive for asking, which is, tell me about your sheep and your wheat. We've talked a lot about your cotton, but that's not the only thing you grow.
That's right. And I have the sheep and the wheat for the soil and rotation, because for conventional cotton, you might be able to grow cotton again and again and again. But in organic, we must rotate. Mm-hmm. And we must rotate with crops that would break any potential disease, a life cycle up. And so at first, I was growing spelt as a rotation with my cotton. I love spelt. I think it's a fantastic crop, but I didn't have the capacity to get spelt. It has something like rice. It has a hull, like rice has a hull. I need specialized equipment to take the hull off, and there isn't any for little farms. And then I met this woman named Monica Spiller, and she is from England, and she's a nutritionist, and her husband was a professor at Stanford, and she was trying to revive the old wheats, the heirloom wheats. Her thought is that people don't eat whole wheat things because they taste bad. And why do they taste bad? Well, they taste bad because in the 1880s, they developed a kind of mill, a new mill that was different than a stone mill that people ground wheat on before the 1880s. The new mill removed the bran and the germ and left you with just the starchy part that could be stored for years without it going rancid. So this changed the whole wheat business. You used to have to grind your wheat and use it within 3 months for it not to go rancid because of the oil component in the wheat. If you actually have a stone mill, you can't store your flour indefinitely. It's only good for a few months, unless you freeze it or something, because the oil in the wheat goes rancid. So she thought that the reason people didn't eat whole wheat is because the modern wheats have all been bred with the bran portion removed, and nobody cared what it tasted like. And so when people started reviving whole wheat, they just took the regular wheats people are growing nowadays, stone ground them where you actually tasted the flavor, and it was bitter. And people don't like whole wheat for that reason. So she went to the seed bank and got a lot of the old wheats and grew them up. And for a few years, she had her plots on my farm. And I got exposed to this one that I went crazy about named Sonora. And I started increasing it with the hopes of getting, I grew big amounts of it for her and then for everyone so that other people could grow it. And it's being grown all over now. It took off, and it's even on the slow food arc of taste. But that's because I believed in it and grew it and grew it and grew it and went around. I was like this evangelical Sonora person. I've taught so many people into growing it. Okay, so here's the fun thing. So not only does it taste wonderful as a whole wheat, because it's like a buttery flavor and there's no bitterness. The main reason I've grown it all these years, besides its great flavor, is that it has the root system of a perennial. So it hardly produces any grain. It produces 1/10 the grain that a modern wheat grows. It's wonderful flavor, but I mean, if everyone grew this, we actually would have problems in the world. It's not the right variety to feed the world, but what it is the right variety for is bringing carbon into the soil because it has the root system of a perennial, and it brings carbon way down deep into the soil where the surface management of the soil is not, where you're not subject to losing the carbon that's brought down because the roots are so deep. And that's also what cotton roots are. Cotton roots are deep. They go down 3-4 feet. So think about the root system of the plant is a system of bringing the carbon that's in the air down deep into the soil. And where we lose the most carbon in our practices of farming are the top 6 inches. That's where you cultivate or whatever you do at those top 6 inches is constantly changing. The carbon there, you don't even bother testing because it's up and down, up and down, up and down. What you care about, what you want to do is get the carbon down below a foot and in a form where it stays as carbon and it's not released into the atmosphere. And there are a number of ways to do that. The root system of the plant is number one importance, in my opinion. And then there are also, there's a whole family of mycorrhiza, which are a kind of fungus that connects one root of one plant to another and to the soil in a symbiotic way that allows nutrients to go back and forth more readily. And a lot of people actually think it's sort of a way they communicate, that it's sort of like the web. The fungi create a communication mechanism between roots of different plants. So if you have the right mycorrhizae, the carbon that the plant puts down in the form of roots can stay in the soil for 50 years or longer if the right mycorrhizae is there. And so I've inoculated all my fields with it, but this is standard for organic farms. You just don't know that this is the stuff we all do.
My cousin has a farm on the eastern end of Long Island that follows organic practices, and she started it. It's called Amber Waves. She started it as a heritage wheat project, and everyone told her, you can't grow wheat on Long Island. And she said, well, somebody should have told the farmers from a century ago that they couldn't do that. And yeah, so she's been doing that for about 10 years now.
Oh, wow. And what does she grow?
I don't know what variety, I'm afraid. I don't know. I mean, they have a whole vegetable operation, but I think she has a winter wheat. Next time I see her, I'll ask her.
Oh, good. How fun. Well, so that's how I got into wheat. And then the sheep are sort of this other story. Like, okay, so before I even started with the cotton, I was spinning all these natural colors of natural fibers, right? And there was this couple that were incredibly critical towards establishing biological control of insects on the Western United States. Their name were Helga and Bill Olkowski, and they taught at a university called Antioch West. And they inspired me, among many others, to study biological control of insects. And they had a farm that they had in Winters, which is about 20 miles south of me. And it was kind of a research farm. And they specialized in biological control of not just insects, but weeds as well. And they participated in a program to import these special brown merino sheep from Australia at like $8,000 a sheep.
Wow.
With the University of California and some other group, because they were found to be the best at eating this weed that we have out here called star thistle. It was an introduced plant that kind of is really a problematic weed, star thistle. And these sheep were what they thought would be the key to eliminating star thistle through grazing. They preferred star thistle, which is why they brought these sheep from Australia through the university. When they got too old to handle their farm anymore and sold it, they had some young people ran it for them for a while, and then someone made the decision that all the sheep were going to go to slaughter. And it was the day before they were all going to slaughter that my neighbors down the road said to me, "Oh, do you want to go buy some of these sheep from the Olkowskis that they're closing their farm?" I had a horse trailer. We had access to a horse trailer. Over there, I decided I would buy 6 sheep. Because I didn't have sheep and I didn't know anything about sheep, but I had border collies and I had studied, sheep herding with my dogs and all that, but I didn't have any experience. I go to get 6, I pay for 6 sheep, and the people working there were so upset that all their favorite sheep were going to be killed the next day that they shoved 30 sheep into the horse trailer. And I came home with 30. 3 days later, they all started having lambs.
Oh my gosh.
And I'm like, oh my God, I'm living on this farm in a travel trailer and I have no experience with sheep. And I have 30 sheep and lambs everywhere and I don't know anything. And so that was the year 2000. And I've had them now 24 years. I've gotten to, they've changed my life and they're intrinsic to my soil, to my farm's soil life. Because I don't have to mow or disc or anything as much as anybody who doesn't have sheep eating everything down, eating all the stubble down. And so, yeah. And on top of that, I have this dream fabric that I want to produce with their wool. The colors, they have colors, and it's super fine merino. So someday I hope to have the yarn, these beautiful yarns that combine the color of the wool and the color of my cotton. We'll see.
Because we've been talking about growing cotton and partnerships with mills, but if people go to your site, they can also, purchase textiles that you've designed and that you've had milled.
Yes, because I had to prove that all these things could be done. I worked with research mills and then learned how to go into production mills. And there is a mill in the United States that's a production spinner. And there are a few left, knitters and weavers that I will, when I have the money, pay to have the various things made. And then sometimes I have one left of the tank top that a friend of mine is a wonderful designer, did the pattern. And then I had them produced in San Francisco. And, so I do dabble with production of various things. The baby blanket that I have is the best example of that. And I tell the stories in my newsletters of these various things. So I have a little section on my website with the links to the newsletters that you can click on and read. But I kind of hope that people get from my website is the feeling that all of us together make a difference. And just to go back to the 90s when we had a textile industry that was vital here in the US, Europe, and Japan, and I was selling to all those mills before they all went out of business, before the decimation from the mass production of fabrics and then clothing coming from the parts of the world that were unregulated. Before that happened, there was this profound chance to change the story, right? And we were very close to it. And then it was swept away by the powers that wanted the cheap, massive profit. And at that very moment, a lot of people came on the market with colored cottons that washed out, that when you wash them, they just wash out. And so what I feel like people in textiles and in crafts, I hope that they come to appreciate what their small actions of support of my work has actually done. Like none of this would have ever happened. The organic land nowadays, it's all died and whatever. All those people that got into organic started out with the organic cotton that was this cotton that was growing at scale. Mm-hmm. And when it all went to these other parts of the world, yes, my cotton was lost. And I went out of business and just found myself here on this farm in a travel trailer, right? And with what I thought would be 6 sheep turned into 30 and trying to figure out how to keep this thing from being lost entirely. Mm-hmm. But none of this, there wouldn't be organic cotton, there wouldn't be GOTS, there wouldn't be any of this if it hadn't been for the hand spinners and hand weavers of this country and the world, actually, that were buying from me, mm-hmm. who supported my work. So just like I say that there wouldn't be all these regenerative, all this talk about using cover crops, using compost, all these conventional farmers who are now talking about regenerative farming and sequestering carbon, all the knowledge of this came from the original organic farmers who developed all these systems and allowed universities to come and quantify the results of using cover crops, the results of the soil organic matter with using compost. They supported those industries of compost companies and cover crop companies. They supported all these things. And that's why these companies exist. And that's why the general population of farmers now who are not organic can still take particular techniques and incorporate them into their farms and now get the support from these carbon credit companies. Mm-hmm. They can be supported doing these things that we all figured out on our own and did it because we wanted to make the world a better place.
So if people are wanting to support you in the work you're doing now and all of your various projects, what's the best way that somebody can be part of it, can support you?
Well, they can buy things from my website. They can donate on my website. They can, I think that's about it at this point, is buy and donate.
Yeah. All right. Well, Sally, thank you so much for your time. I've so enjoyed this and I can't wait to explore what's happening next. Thank you so much.
Well, thank you. Thank you for being interested.
Thanks to our sponsors for supporting the podcast. Thank you for listening to the Long Thread podcast. If you've enjoyed this episode, please rate the show and leave us a comment on Apple Podcasts or your favorite podcast platform. Thanks again.